This is the first part of lesson 2.1. It's an introduction to linear equations. So to start off, let's see what you know. Try not to use a calculator for the warm-up. Pause your video and see what you know. All right, so for the first ones, we have negative 12 plus 8. So I always imagine I'm looking at a number line. If I'm at negative 12 on the number line and I'm adding, I'm going to be moving to the right. So if I move 8 spaces to the right, I'm still negative, but I'm at negative what? I'm at negative 4. Okay. For number 2, this is multiplication. We use this dot as our multiplication symbol so we don't confuse it with a variable. And for this one, we have negative 8 times 6. So a negative times a positive is a negative. And then 8 times 6 is going to be 48. Okay. For number 3, I see 20 minus negative 5. Now, when I have a minus minus, I need to change them to both positive. You can't subtract a negative. You end up adding. So 20 plus 5 gives me 25. Okay. Negative 12 minus 7. So again, think like we talked about number 1. If you're at negative 12 on a number line and you're subtracting, you're moving left. So you're becoming more negative. So in this one, if I move 7 to the left, I'm at negative 19. Okay. Number 5 is a division problem. So in this one, we have a negative divided by a positive. If our signs are different, it's going to be negative. If the signs are the same, they're going to be positive. So 24 divided by 8, that means how many times 8 go into 24? Well, you can count up by 8. 8, 16, 24, that's 3 times. Okay. For the second part, combining like terms, this is just an intro into what we're talking about today. So in this case, we have 4 x's and we add 7 x's to them. They are like terms because they both have an x. So 4 plus 7 is going to be 11x. Okay. In number 7, you have to watch out. 9x minus 3x, those are like terms. So 9 minus 3 is 6x. But this 6 over here is not a like term because it doesn't have an x on it. So we're going to keep the plus 6 by itself. And this is how we have to leave it. Okay. For today's lesson, there are guided notes in the Schoology folder for you. You can follow along as we go. Just pause your video from time to time so you can fill in your notes. All right, so to start off, to combine like terms, you first have to use the commutative property to move all your terms together. Some people really have to see those terms side by side, but some people can look at them and know exactly which ones go together. Okay, like terms are ones that have the same variables, okay? And the coefficients are the numbers that are in front. So let's look at example 1. So we have 2a plus 3b minus 4a. So I can tell that 2a and negative 4a are like terms, so I'm going to slide them next to each other. Okay. Now, here's a little hint for you. Any symbol goes along with whatever's behind it. So although this 2a has no symbol in front of it, there's an imaginary plus sign that goes with that. This plus sign goes with the 3b, and then the negative goes with the 4a. So it's whatever is behind it goes with that symbol. Okay. So they move the 2a and the negative 4a together, and then they just put the plus 3b at the end. Well, since these two are like terms, like we saw in the warm-up, you can do 2a minus 4a and get negative 2a. And then the 3b is just by itself. Okay, it cannot be combined because the a's are different than the b's. Okay, in this example, they've already color-coded it for you, and this is something that I like to do, especially if we were in class together. I would have you guys color code. So anything that has m's, they colored in red. Anything that has an n squared, they colored in blue. If you don't have color pencils, you can do boxes and circles and triangles, whatever you need to distinguish between each one. Okay, so what I'm going to do is I'm going to take my 14m and my 3m and I'm going to put them side by side. Plus 3m. And then I'm going to take these two and put them side by side. So negative 3n squared, negative 2n squared. Okay, so since these two are like terms, I can do 14m plus 3m. So that gives me 17m. And then since these two are like terms, I can combine them together. Negative 3 plus negative 2 gives me negative 5 n squared. These two pieces cannot be combined together because one has an m and the other one has an n squared. Okay, let's try the last example. So in this case, this time I'm not going to rearrange them. I'm just going to keep them how they are. And what I like to look for is I look for the highest exponent. So this guy is the only one, so that's going to go first. That's a positive 5x squared. Okay, then I'm going to look for my x's. Well, I have two of them right here. I can combine those two together. Okay, 5x plus 4x gives me positive 9x. And then my last term is this negative 6. Okay, that is all by itself. There's no variable. So that's going to be at the end. That's called a constant. Okay, constant is just a number that's by itself. Now, if you notice, this one has an x squared, this one has an x, this one has nothing. So these three things cannot be combined together. Okay, watch out for the following common mistakes. These are things that we see all the time. So in this case, you can only combine terms when the variable has the same exponent. So this one has an a squared. These two do not. So in this case, only these two could be combined, not all three of them. Okay, so the exponents make them different. Okay, mistake number 2, you should always put the variables of your answers in alphabetical order, then by exponent order. So in this case, x comes before y, so our x value should have came first, and then our y values. Okay, so we always try to stick in alphabetical order. Mistake number 3, you should always move the negative sign along with the term that's after, and that's what we talked about before. So in this case, they have 3h, but this negative really goes along with the 5h. So this should be a negative 5h here, not a positive, which is going to totally change our answer. Okay? And same thing. This one is a positive 5g, not negative, so that should be a positive there. So our answers would be totally different. Okay? So what I want you to do is I want you to pause this video, and I would like you to follow this on your guided notes. It says, circle all terms that can be combined with 3a. Draw a square around all terms that can be combined with 4b. Underline all terms that can be combined with a squared. And then draw an x through all the terms that can be combined with 5. And then once you get done that top part, you're going to go ahead and show how you would simplify the 3 that are at the bottom using like terms. All right, so it says circle all terms that can be combined with 3a. So we are looking for any numbers that have an a in them. So number 1, 14a, could be combined with 3a. So we're going to circle that. Now this one cannot because it has a, b. If it was just a, we'd be able to combine that. This one has a b. This one has an a squared. And like we talked about in the common mistakes, a squared is different than just an a. So that cannot be combined. So if you're looking on here, the only other one that can be combined with that would be 4a. Okay. Then we're going to draw a square around anything that can be combined with 4b. So we're looking for things that have just a b. So we have 3b. And let's see what else we have. We have 16b, can also go along with that. All right, but our ones that have ab don't work. The ones that have b squared don't work. Okay, the next one says underline all terms that can be combined with a squared. So we're looking for all of the ones that have a squared, like 3a squared, 73a squared, and that looks like that's all of them. And then the final one says draw an x through terms that can be combined with 5. 5 is a constant. It's just a number by itself. So you can only combine constants with constants. So 17 is a constant, and so is 100. Okay, so you see there are a few other ones that we did not choose, and that's fine. Okay, now simplifying these ones down here. 4x and negative 6x have like terms. They both have an x, so we can combine them. 4 minus 6 is negative 2x. Okay, here we have all y's, so all of these can be combined. Well, I can see that 5y minus 5y, that's going to be 0. So 7y plus 0 is 7y. Now be careful with this one. I have an R, I have a Y, and I have a constant. All three of those things are different, so we cannot combine this one. So this is exactly how we would leave it. All right, go ahead and pause your video and see if you can try combining like terms for these ones on the screen. All right, for number 16, I see I have the variables m and n. So thinking back to what our rules said, we have to go in alphabetical order. So our m's are going to go before our n's. So in this case, I have a 3m, and then I have positive 4n and negative 6n. So I'm going to combine my like terms. 3m has nothing to go with it. And then what is 4n minus 6n? Well, we just did that on the screen before. 4 minus 6 gives us negative 2n. So this is how we're going to leave our expression. Okay, in 17, all of these have g's, so they all can be combined together. So 4g plus 6g, well, that's 10g. 10g minus 3g is 7g. Okay. For 18, we have one that has an f, we have a constant, and we have another f. So what you want to do is you want to put your letters first, and you always want the constant by itself at the end. So 15f plus 2f, that gives us 17f. And then our minus 5, we just kind of move to the end. Okay. All right, for 19, let's see what we have. We have 13x and a 4x. They're like terms, positive 4x. And then we have this negative 7y that is not a like term. So thinking alphabetical order, our x's have to go first. So 13x plus 4x is 17x. And then our minus 7y can just go at the end. All right, number 20, be careful. X squared is different than x. So these two can be combined together, but this one cannot be combined. So because we have x's, we have to go with the highest exponent first. So 5x squared plus 9x squared is 14x squared. We want our highest exponent first, and then our negative 4x is just going to follow behind. Okay. Now this one, if you notice, we have a B, we have an A, and we have a constant. They are not like terms, so they cannot be combined together. But what we can do is we can put them in order according to the variables. So remember, alphabetical order, the 7A would go in the front, then our positive 4B, and then last would be our constant. So we can just rearrange that one. All right, when it comes to solving an equation, what is our goal? Well, in this case, our goal is to figure out what x is equal to, and we want to get x by itself. So all of our answers should say x equals something. How do you solve equations? You use the inverse operations or keep undoing operations until x is by itself. Okay, so here are our inverse operations. The opposite of adding is subtracting. So these two go together. The opposite of multiplying is dividing. Okay, and it works the opposite way as well, subtracting and addition, division and multiplication. Okay, these are all one-step equations. So I'm going to do 2 of them with you, and I'm going to have you guys solve the rest of them by pausing your video. So the very first thing I want to do is I want to get x by itself. So what I like to do is take my pen and I like to draw a box around the variable that I want to be by itself. Okay, I also like to take my pen and draw a line down from the equal sign. Okay, now on the same side of the x, I have this minus 4. That minus 4 has to move. So the inverse of minus 4 will be to add 4. Whatever you do to one side of that equation, you have to make sure you do the same thing to the other side. Well, negative 4 plus 4 are going to cancel out. So x is by itself. And then negative 12 plus 4, remember, we're becoming less negative. We're heading closer to 0. So 12, 11, 10, 9, 8. This would be negative 8. If you want to double check to see if you're correct, You could substitute -8 in the original. -8 minus 4 does give us -12. All right, let's try this one over here. Same thing, I'm drawing a line down for my equal sign. I'm putting a box around my variable. Now this 6 is positive. Even though there's nothing in front of it, there's an imaginary positive symbol there. And this positive goes with the x. The opposite of adding 6 would be to subtract 6 from both sides. Okay, so x is by itself, and then 14 minus 6. So that would be 8. Okay, and again, you can double check. If you plug 8 in for x, 6 plus 8 is 14. Okay, so there are a few others here. Go ahead and see if you guys can pause your video and check out these problems. All right, for number 3, here's our x that we want by itself. The opposite of subtracting 6 would be to add 6 to both sides. So we have -20 plus 6, so we're going to work backwards. So count back 6, 19, 18, 17, 16, 15, 14. We'd be at -14. Okay, for number 4, I'm doing the same thing I did for all my other ones. The opposite of subtracting 10 would be to add 10. So we get x equals 25. All right, over here, now you see my x and my -5 are side by side with no symbol in between. That means that's multiplication. So think about, what is the inverse of multiplication? Well, the inverse is division. So we're going to divide both sides by -5. Okay, 45 divided by -5 is -9. Okay, over here, this is the opposite. So here we want our x by herself. I see a division bar here. So this is x divided by -3. So I want to multiply each side by -3 because the inverse of division is multiplication. What happens when you multiply by -3 and divide, they cancel out. Okay, and 7 times -3 is -21. Okay, all of these that you saw were one-step equations. You had to do one thing to both sides to get your final answer. Now we're talking about two-step equations. So we're going to have to do two different things. So I'm going to start the same way I did my other equations. Okay, I'm drawing a line from my equal sign, and I'm circling or putting a box around anything that has an x. Right now, 3 and x are tied together. We can't touch that 3 yet because they're connected. But I can move this -7. What's the opposite of subtracting 7 with inverse? Is to add 7. Okay, so we have 3x equals 11 plus 7 is 18. Now I can take care of the 3. 3 is connected to x by multiplication, so the inverse would be to divide by 3. All right, so these cancel out. X equals 18 divided by 3 is 6. So we did 2 steps that time. We added and then we divided. All right, let's look at number 2. I'm going to start the same way. I can't touch the 2 yet because that's connected really close to the x, so I have to move the 5. 5 is positive, so the inverse would be to subtract 5. Okay, so 2x can come down. -17 minus 5 is going to be negative. And then you got to think 17 plus 5, 22. All right, last step. To get 2 and x to separate, we have to divide them by 2. Whatever is in front of your x is what you divide by. So x equals -11. All right, let's take a look at these ones. So I have -4 and x are connected. The inverse of subtracting 10 would be to add 10. So we have -4x equals 10 plus 10 is 20. And then the inverse of this multiplication would be to divide by -4. So x equals -5. All right, in number 4. Okay, right now, X and this 4 are connected, so I can't touch that yet, but I can move the 6. So I'm going to subtract 6 from both sides. So I have X divided by 4 equals 6. And then just like in our examples on the page before, when you have division, the inverse is to multiply. So we're going to multiply both sides by 4. So we get X equals 24. Okay, and just like before, if you want to double check these, you can take your answer and substitute it back into your equation. 24 divided by 4 plus 6 does give us 12. Okay, all right, it's your turn to try these. These are a combination of 1 and 2-step equations. Pause your video and then come back and check your answers. All right, for number 1, this is a 1-step equation. So the only way to break up -4 and X is to divide by -4. Okay, so X equals -3. Number 2 is a 2-step equation. 5 and X are connected to each other, so we have to move the -8 first. The opposite or inverse of subtracting 8 would be to add 8. Okay, so we get 5X equals 20. And then the inverse of multiplication would be to divide. So X equals 4. All right, down here, 3 and X are connected. So I have to move my +9 by subtracting 9. So I have 3X equals 6. And then if I divide both sides by 3, I get X equals 2. All right, finally, number 4. Again, -2 and X are connected. The only way to move -7 is to add 7 to both sides. So I have -2X equals 12. And then finally, if you divide by -2, you get X equals -6. All right, so your exit ticket is on Schoology. There are a few questions that you have to combine like terms. So remember we talked about you have to only combine terms that have the same variable. You want to make sure that they're in alphabetical order and that if you have a constant, like for example, -4 and 20 are constants, when you combine those together, constants go at the end. Solving equations, you're going to see some 1 and 2-step equations. Actually, all of these are 2-step equations. So please solve those on Schoology. If you have any questions, I will be available in our virtual classroom and I'll be happy to go through anything with you.